In this lesson, we're going to learn how to create IPO tables. Now, an IPO table is used to analyze your problem statement when you're doing any kind of software development. What we'll seek to do in this lesson is we're going to try and help you understand why a piece of information goes in a particular column, what piece of information is not supposed to be in a particular column, and how this can aid us in explaining what we are trying to achieve to a person who is a non-programmer. So, as already stated, IPO stands for input process output tables, and because of that, we're going to have to start off with a few definitions, and we're going to define what the input process and the output is. So let me just write out the first one, which is input. Now, in some cases, such as a search program, you're not going to provide any kind of input. For example, if you're looking for the prime numbers, what you're going to do is you're going to just keep going through the various numbers, keep increasing it by one, and then you're going to determine whether or not that number is a prime number. If it's a prime number, you show it. If it's not a prime number, you don't show it. I'm just saying this for the instance when you go further on and you look at IPO tables and you're assuming that you must have information on each one of the columns. It's not true that you must have information on each one of the columns. You can have a blank column. You can usually put in a none inside of it just to state that there's no input, or there's no output, or there's no process that you're going to have to do. But most of the time, the only thing that could possibly be blank is your input or your output. Now, when you're creating a table, the first thing you can decide on is whether or not you want the table to be vertical or horizontal. I personally prefer a horizontal table instead of a vertical table because I can easier see all the information and all the steps involved, because what I do is I put each part in as bullet points. And when you're creating the IPO table, you have to try and remember what you're trying to do is you're communicating with persons who are not programmers. And this is a way for you to identify for them your understanding of the problem that they are providing for you. For example, when you're creating software, you're not going to speak to a person who is a programmer. You're going to speak to a person who is not a programmer. You can create this IPO table and provide it to them, and what they will do is they will read and see whether or not the model that you've developed with that IPO table is what they desire. So try to use non-technical information, try to use simple words as much as possible, and try when you're stating your input, your process, and your output, you try and put a little bit of a sentence in there. I'm not talking about a sentence to the point that you explicitly say what you're taking from where you're getting it. What I mean is that your inputs are descriptive enough with a few words, not just a one-word answer. For example, if I'm taking 5 numbers, right? I'm not going to put in something like this, 5 nums, as my input, because I don't understand. Somebody who is reading this for the first time is not going to understand what 5 nums mean. It may be beneficial, it's simple for you and you can understand it, but somebody else is not. So what you would just say is you can say enter 5 numbers, right? And don't shorten your words. You're not going to be using any variable names. You're not going to have to use any kind of data types, because as I said, this is a way to communicate your understanding of the problem to a person who is a non-programmer. So this here is what your typical input process output table is going to look like. When you're stating the inputs, now I'm going to just put in a little few notes inside of these sections here relevant to the columns themselves. So when you're putting in any information in the input, be descriptive. You want to state exactly what your variable, not your variable, sorry, you want to state exactly what your inputs are. You don't want to be shorthanding the words. You don't want to be making it vague. You don't want to make it so that only you understand what it means. You don't need to put in any variable names. And you don't need to put in any data types. As I said, this is a problem analysis. This is not the implementation. And when you're going into process, you would understand this even more. When you're writing something such as your processes, you don't want to have any details of implementation. And when I mean details of implementation, I'm saying something such as, again, when you're finding an average and you enter the 5 numbers that we talked about before, you don't want to talk about the fact that how you go about adding the numbers together. You don't want to go about the fact of how you're going to do the divisions. And I'm talking about the addition operations and the division operations. These are things that are done with the programming language itself. All you have to do is say something like sum the values, sum the numbers, and then divide the numbers by 5 to get your average. And that's it. You don't have to go into how you're going to implement it. You don't have to go into great detail about any equations. Right? And again, what I mean by great detail is explaining how you do additions and subtractions and divisions. You're not going to need to do that. And to determine if something should be placed in the process column, all you have to do is just think of the general steps. Right? You're thinking of the general steps involved in taking your input, processing it, and producing an output. So you just want the general steps. From there, you would be able to do an output part of your table, and the output part of the table is not supposed to be how you want it displayed. It is a matter of what is to be displayed. For example, if it is that you're doing the planning for a tic-tac-toe game, you're not going to put on your output that you're going to display the board and how you're going to display the board. For example, you're not going to explain that you're going to use some dashes for this part, you're going to use a pipe for this part, you're going to use a space here, you're going to use some more dashes here, like such, and you're not going to go into the great detail of how you're going to display your data. Right? You're not going to go into great detail about how you're going to display information. All you're going to do is you're going to say you're going to display the board. You're not going to show how you're going to display the board. And that is it. That's all the information that you really need to understand when you're doing an input process output. So what I'm going to do now is I'm just going to look at a couple of examples, and these examples are taken from the list of programs to implement. I'm just going to put the name of the program that you have to implement. Actually, I can put in the question themselves. So this is the first problem that I'm going to use as an example to implement. You would find this in the programs to implement document in the course information. Right, so we first want to create the table. So we're going to start off with input. Then what we're going to do is we're going to read the entire question and highlight the parts that are important for us. So I'm just going to create a little highlighter here. Right. So I'm going to start off with yellow highlighter for the input parts. So I'm saying, they say write a program that reads the subtotal. Keyword here is reads. So you see in right away we say reads the subtotal and the gratuity read. Right? Notice that you already have the information desired for the input. Then it's also telling you what is going to be computed. You are to then compute the gratuity and the total. Right? So you are to then compute the gratuity and the total. And then finally, what you're going to do is you're going to display gratuity. So the program displays that as gratuity and that as the total. So notice you're already from the question able to understand what information you're going to be taking in, what you're going to be processing, and what you're going to be producing as your output. So I'm just going to write in the information here. So on the first one, we're going to say you're going to take the subtotal of the bill, and you're also going to take the gratuity as a percentage. And then we're going with the process. So for the process, we have it in orange, so I'll write in orange here. So for the process, we're going to say convert the gratuity from percentage to decimal. Then I'm going to use the gratuity as a decimal and the subtotal to determine the value of the gratuity. And then from there, we're going to put the output. We're going to just simply, oh wait, I still have one more thing to do here. Then we have the output. The output was done in pink. And we can look at several more questions, right? And I'm not going to go into the details of how I did it here. I'm just going to go in and highlight the pieces of information that would tell you what goes where. And I'll keep the same color code of what, yellow, orange, pink. I'll keep that same color code. Right, yellow. So we have to read an integer, right? Let me just, right. So we have to read an integer. So this here between 0 and 1000, right? And from that part, the next thing that we have to do is we have to process that by extracting the digits, and right, we're going to process that by extracting the digits. We're going to process that by extracting the digits and add all the digits of the integer together. So this is part of your processing. Then from there, you're going to just display the sum of all the digits, as the example already suggested. All right, so you have three things that you're going to do there. You're going to take in an input between 0 and 1000. You're going to add the digits up in the integer, and you do this by simply separating the digits or extracting each one of the digits, and then you're going to add all the digits up together, and you're going to display that sum there at the end. Let's look at another example. Now let's look at some prime here again. It says write a program that stores 50 prime numbers in an array and displays them to the screen 5 per line separated by a single space. Now right now you don't have anything for input, and this is one of the examples that I was talking about earlier. You don't have any inputs here to talk about. All right, there's nothing you're really doing. You're just simply going through all the numbers that you want until you get 50, you meet the condition of 50 prime numbers. So there's no input here. However, there is a process, and the process is to determine prime numbers, right? The process is to determine prime numbers. So you just keep going until you identify prime numbers. Right? This is what your process should entail, looking for your prime numbers. Right? Once you find your prime numbers, then you're going to display your prime numbers 5 per line. Right? And they tell you how they want that displayed. You don't have to go about stating that you want to display them on the screen 5 per line. As I said, you don't want to state any conditions of how to display it. You just want to state what is to be displayed. So right away, your idea should come that you have no input on your table. You should be able to determine if the number is a prime number, and then you should store that prime number in the array. That's part of your process. And for the output, you would just say display the array of prime numbers, and that's all. this method of displaying 5 per line, you have to consider that when you're writing the actual program or you're planning the program itself. You're not interested in that right now. Right now, all you're interested in understanding what the problem is. The problem is identifying primes and then storing primes in an array so that you can display them later. That's it. We're going to look at another example. Now this example is a little bit longer, so let's look at it. It says write a program that prompts the user to enter the center coordinate and the radii of 2 circles. And then that is it. Next part, we have to do some processing, and it says to determine whether the second circle is inside the first or overlaps the first. And they give you a hint here to deal with that situation in terms of information for processing. For instance, it said circle 2 is inside of circle 1 if the distance between the two centers is less than or equal to the absolute value of the difference between the 2 radii. And that's a long piece of information, right? Then they give you a next part that said circle 2 overlaps circle 1 if the distance between the 2 centers is less than or equal to the sum of the 2 radii. And they say test your program to cover all cases. Now, if you watch right away, you can see that the information that is required to be displayed is inside of your processing information. For example, if you look right here, you can see that you're looking for a condition where circle 2 is inside of circle 1, right? And then you have to say if circle 2 overlaps circle 1. Notice that the information for processing contains what is required for you to display. And I'll just highlight the entire sentence right here, right? And you'd be able to see that your hint also contains what you are required to display for your problem, right? So if I run a summary of the information that I pulled from there, you can see right away that from here, the yellow part, you can see that I'm supposed to take the center of the first circle, the radius of the first circle, the center of a second circle, the radius of a second circle. Then I have to determine the distance between the 2 centers. Then I have to determine the absolute value of the difference between the 2 radii. Then I have to determine the sum of the 2 radii. And then I have to compare the distance between the 2 centers with the absolute value of the difference between the 2 radii and the sum of the 2 radii to determine the relative positions of the circles. And once I determine the relative position of the circle, I just have to display that relative position in terms of if the circle is inside or if the circle overlaps or if the circle is outside. Looking at another example, we are seeing that I am supposed to write the functions of with the following headers. So they tell me what 2 headers are. I don't have to develop these headers on my own, but they say to use cube of digits to implement is Armstrong. An integer is an Armstrong integer if the sum of the cubes of its digits is equal to the number itself. Write a test program that prompts the user to enter an integer and reports whether it is an Armstrong integer. So right away you identify your input, right? We have to enter an integer. Then we are looking at the processing. We want to find out the cube of digits and we want to find out is Armstrong. So those are 2 processes that you're going to have to deal with. And once you deal with those 2 processes, the output is very simple. We just have to state if an integer is an Armstrong integer, right? And that's it. We identify every single thing that we need for that problem statement to go in our input-output process table. So again, the input is that we require an integer or require a number, and then the process is that we have to determine the sum of the cube of the digits in the numbers, and then we have to compare the sum of the digits in the number and the number to determine whether or not it's an Armstrong number, because remember what they said is an integer is an Armstrong integer if the sum of the cube of its digits is equal to the number itself. And then finally what we're displaying is whether or not that number is an Armstrong number, right? So those are the examples that we're going to look at, and if it is that you don't understand anything, just refer to the document for the course and you should be able to understand more of the content. What I require for you all to do is that after you look through the examples and you look through the various IPO tables that I created in the document, once you read the document, you understand how it is that you analyze the input process output your problem statement with an IPO table, then what I would like you all to do is I would like you all to use the other programs that were not used for examples and see if you can develop IPO tables for each of them. So you are required to do any program that is not used here and as an example and create your own IPO table for them. All right, so if you have any questions, just feel free to message me and I'll be able to get back to you. Good luck.